All right, let's dive in. We've got this super interesting article from Knowable magazine. It's called Solving Renewable Energy's Sticky Storage Problem.
Oh, yeah, I saw that one.
And it got me thinking about, like all the progress we've made with renewables.
Yeah,
But there's this one big hurdle we got to clear.
definitely.
And it's all about storage. Like what happens when the sun goes down or the wind stops blowing.
Right.
The article actually starts with a pretty dramatic example.
Oh, yeah.
Germany, they've gone all in on wind and solar. They're producing a ton of clean energy, sometimes even more than they need.
Wow.
But then, bam, they get hit with this thing they call Dunkelflaut.
Dunkelflaut.
It's like a German word for basically when you have days, maybe even a week,
Okay.
of low wind and weak sunshine.
Oh, so like the ultimate renewable energy challenge.
Yeah, exactly. Like, how do you keep the lights on when nature's battery pack is running low?
That's a tough one.
And the article dives into some pretty mind-blowing potential solutions.
I'm all ears.
So I gotta ask, what's the first thing that comes to mind when you think about energy storage?
Well, I mean, the obvious answer is batteries, right?
Right, batteries, specifically lithium-ion batteries.
The workhorses of the modern world.
Yeah, they're in our phones, our laptops, electric cars.
Pretty much everywhere you look.
But the article makes a really interesting point about lithium-ion. They're awesome for, short-term storage, smoothing out those daily ups and downs in the grid.
Yeah.
But when you're talking about storing energy for days on end, lithium-ion kind of hits a wall.
Yeah, I see where you're going with this.
Yeah, imagine trying to build a battery big enough to power a city for a week.
It'd be enormous.
And incredibly expensive. The article actually mentions, a battery capable of supplying 1 megawatt every hour for 5 hours
Okay.
would cost at least $500,000.
Wow, that's a lot just for 5 hours.
And that's just the tip of the iceberg. Plus, you got to think about the sheer size of these things.
Right.
Where would you even put them?
Good point.
So, okay, lithium-ion might not be the ultimate answer for a long-duration storage.
Seems like we need to think outside the battery box.
Yeah, exactly. And that's where things get really interesting.
Intrigued.
The article dives into a bunch of really cool alternative technologies that are, in the running to solve this storage problem.
Oh, this is my favorite part.
Okay, so first up, we've got something called sodium-ion batteries.
Sodium ion, like table salt sodium.
Yeah, pretty much.
Interesting.
Instead of using lithium, which is, getting kind of pricey and hard to come on.
Right.
Sodium-ion batteries use, sodium.
Which is everywhere.
Exactly. It's way more abundant and cheaper.
So potentially a game changer in terms of cost.
Yeah, that's the idea. They're not quite ready for prime time yet, but the research is moving super fast.
Exciting times.
Okay, next contender, get ready for this, redox flow batteries.
Redox flow.
I know, it sounds kind of sci-fi.
It
But basically, instead of having solid electrodes like a regular battery,
Okay.
they use these two big tanks of liquid electrolytes.
So like a battery made of chemicals sloshing around.
Pretty much. And the crazy thing is, you can potentially scale them up massively.
Wait, really?
Yeah, imagine a battery the size of a football field.
Wow.
Powering a small town for a whole week. That's the kind of potential we're talking about with redox flow.
That's insane.
I know, right?
All right, what else we got?
All right, buckle up for this one because this might be my favorite just because it sounds so cool.
Okay.
Iron air batteries.
Iron air, what's that?
They basically work by, unrusting metal to release the stored energy.
Like reversing rust.
Yeah, kind of. Isn't that wild?
That's pretty awesome.
And there's this company, Form Energy. They're actually building a huge factory for these things in West Virginia.
Oh, wow, so they're serious about it.
Yeah, it seems like a really promising technology, especially because the materials are so cheap.
Just iron and air, right.
Yep. But there's a catch, of course.
There's always a catch.
They're not as efficient as some of the other options.
What do you mean?
Well, you lose some energy during the conversion process, like storing it to releasing it.
I see.
So there are trade-offs with everything.
Makes sense.
It's not like there's one magic bullet solution.
Definitely not.
But it's fascinating to see all these different approaches.
Absolutely.
We're just getting started.
Oh, there's more.
Oh, yeah, the article goes even further, talking about some even wilder ideas.
Okay, lay it on me.
We're talking giant spinning disks, storing energy like a supercharged bicycle wheel.
Wait, what?
And underground caverns filled with compressed air, like giant air batteries.
You're kidding, right?
Nope, it's all in there. We'll get into those next time, but I'm telling you, it's some seriously mind-blowing stuff.
Can't wait.
So stay tuned. We've got a lot more ground to cover in this energy storage deep dive.
I'm ready for it. It's really a horse race, isn't it? Like all these different technologies are jockeying for position.
Totally, but it's not like we're going to crown one winner and call it a day, right?
No way. It's way more nuanced than that.
Okay, so let's break it down. For everyday energy storage, what's looking good?
Well, lithium-ion's still a solid contender.
Yeah.
At least for, covering those short-term fluctuations.
Like when a cloud passes over a solar farm.
Exactly. But sodium-ion is definitely hot on its heels.
Right. Sodium-ion, it's cheaper, right?
Way cheaper. And the materials are much more abundant. So, long term, it could be a real game changer.
Interesting. Okay, so that's for like the day-to-day stuff. But what about those Dunkelflauten, those multi-day energy droughts?
Ah, yeah, that's the real challenge.
Like, do we just need a bigger battery? Or is it something totally different?
It's probably going to be a mix of things. The article talks about this idea of a layered approach.
Layered approach.
Yeah, like using different technologies for different timescales.
So give me an example. Like, how would that work in practice?
Okay, imagine this. You've got your flywheels, right? Spinning away, ready to smooth out those sudden dips in solar or wind power.
Okay, so flywheels are like the first line of defense.
Exactly. Then you've got compressed air kicking in to cover the next few hours.
So they're kind of like the backup generators?
Kind of, but way cleaner and more efficient. Then, to bridge the gap for several days, you might have redox flow batteries taking over.
Okay, I'm starting to see how this layered approach could work.
And if we're talking about those worst-case scenarios, those prolonged energy droughts, well, that's where hydrogen comes in.
Hydrogen, the ultimate long shot.
Maybe, but it's the only technology we know of that can store weeks or even months' worth of energy.
Okay, so it's like the ultimate insurance policy, like break glass in case of emergency.
Precisely. Even with some energy loss during conversion, hydrogen could be our lifeline during those rare but crucial weeks-long Dunkelflauten.
That's amazing to think about. Like, we could potentially have weeks or even months of energy stored away.
It's mind-blowing. But, there are challenges.
Oh, I'm sure there are.
Scaling up any new technology to meet the needs of entire countries, let alone the whole world, that's a massive undertaking.
Yeah, I can only imagine.
And then there's the cost.
Right, like, wouldn't building all the infrastructure for these technologies, like those giant caverns for compressed air, be incredibly expensive?
It's a huge investment, no doubt. But we have to think about the bigger picture.
The bigger picture.
A resilient, clean energy system could lead to greater energy independence, reduced pollution, a more stable climate. And as the technologies mature, the costs are likely to come down.
Okay, that makes sense.
Plus, we can't just focus on building more storage. We also need to get smarter about how we use energy.
Oh, right, demand management, like shifting our energy use to match supply.
Exactly. It's about encouraging people to use less energy during peak times. Those hot summer afternoons when everyone's cranking up the AC.
But how do you actually get people to change their behavior?
It's a challenge, but not impossible. Think smart grids that can automatically adjust energy use based on real-time conditions.
So like dimming lights during peak demand.
Exactly. Or shifting your EV charging to off-peak hours.
So you come home to a fully charged car without even thinking about it.
That's the idea. And many utility companies are offering programs that pay people to reduce their energy use during peak times.
Well, like, we could actually get paid to save energy?
Yep. It's a win-win situation. You save money, and you're helping to reduce strain on the grid.
I like it. So it sounds like we need this two-pronged approach, building up storage while also getting smarter about how we use energy.
Precisely. It's like two sides of the same coin.
It's amazing to think about how much things are going to change, but there's something in the article that I keep coming back to.
Oh, yeah? What's that?
It's this idea that the real need for long-duration storage won't kick in until solar and wind power make up a much larger percentage of our energy mix.
That's a really interesting point.
Like, why wait? Why not just build it now?
Well, right now, it's still often cheaper to rely on fossil fuels, especially natural gas, to fill those occasional gaps in renewable energy production.
So it's just a matter of economics.
Pretty much. Building massive storage to cover those rare occurrences, it just doesn't make financial sense yet. But as we transition to a grid that's primarily powered by renewables, those gaps will become more frequent and more significant.
And that's when the demand for long-duration storage will really take off.
Exactly. It'll be like flipping a switch in the market.
It's a race against time, isn't it?
It is. We need to develop these solutions quickly enough to keep pace with the growth of renewable energy and prevent us from falling back on fossil fuels.
Okay, I'm starting to get a better sense of how all this fits together, but let's get down to brass tacks. What will this transition actually look like for people in their everyday lives?
Ah, the million-dollar question. That's what we'll explore in the final part of our deep dive.
Okay, I'm on the edge of my seat. Let's get to it. All right, so we've talked about all the different storage options. The challenges, the costs, the whole shebang.
Yeah.
But now I want to know, like, what does this actually mean for me, for the listener, in our daily lives?
It's the big question, right? How will this reshape our world?
Exactly. Paint me a picture. What does a future powered by renewables and all this fancy storage actually look like?
Okay, well, imagine a world where blackouts are a thing of the past.
No more power outages.
Gone. Even those Dunkelflauten we talked about, they can't touch you.
Really?
Your home, your business, everything humming along, powered by a mix of solar, wind, and all these storage solutions working behind the scenes.
It's like we're cutting the cord, breaking free from the old grid.
That's a great way to put it. We could see a much more decentralized energy system.
Decentralized?
Yeah, like Think rooftop solar panels, charging home batteries, neighborhoods becoming mini power grids, sharing energy with each other.
Like those microgrids I've heard about.
Exactly. And electric vehicles, they become more than just cars.
Oh, yeah. How so?
Think of them as mobile energy storage units.
Mobile energy storage.
Yep. You plug in your EV at work, it charges up, but it can also feed power back to the grid during peak demand.
So my car could help power my office.
Exactly. You can even get paid for that.
Wait, really? I could get paid to park my car?
It's possible. And think about the impact this could have on rural communities or places without reliable power.
Yeah, that's a whole other level.
They could leapfrog ahead, build their own clean energy microgrids.
Powered by the sun, the wind, and whatever storage tech works best.
It's a game changer.
Okay, I'm getting really excited about all this, but I gotta ask, are there any downsides?
Of course, every big change comes with its own set of challenges.
Like what?
Well, costs are a big one.
Yeah, that's what I was thinking.
We need to make sure this transition is affordable for everyone, not just the wealthy.
Which brings us back to those policy incentives we talked about.
Exactly. We need policies that support innovation, encourage investment, and make clean energy accessible to all.
And what about the environmental impact, like mining all those materials for batteries? That can't be good for the planet, right?
You're right, we have to be mindful of that. We need to make sure the whole process, from sourcing materials to manufacturing, is done sustainably.
So it's not just about finding new energy sources, it's about changing our whole relationship with energy.
That's it. It's a fundamental shift in how we view and value energy.
Okay, so as we wrap up this deep dive, what's the big takeaway? What do we want our listeners to remember?
We're at the beginning of a massive energy transformation, one that comes with challenges, but also huge opportunities.
It's exciting and maybe a little scary all at the same time.
But it's a story that's still being written, and we all have a role to play in shaping the future of energy.
That's a great way to put it. And to our listener out there, thanks for joining us on this energy storage adventure. We hope it sparked your curiosity and inspired you to think differently about the future. Keep learning, keep asking questions, and let's build a brighter, cleaner energy future together.